Test of a proportion, one or two-tailed. What kind of data is that going to be? Proportion is going to be nominal. Okay, let's have a look at these last three. Are any of those three nominal? Okay, we've got predicting sales as a function of temperature. Would sales be nominal? Yes, no, I don't think so. What ice cream do different groups prefer? Nominal? Yeah, that could be it. Is political party, support for political party over 5%? Yeah, that's nominal as well. So it's one of these two. Okay, and we're testing of a proportion. Test of a proportion. So we're not comparing anything. We're simply seeing a proportion against a value. So it's this one here. Is support for a political party over 5%? So we have one sample. And in fact, this one's different. We actually can get a Z value with it. Or actually, did we? Now that I think about it, we did the binomial. So the usual way to do it is a Z value, but we found the binomial P value when we did that one. That was in lecture 6.1. Okay, now the chi-squared test of independence. This is a nice one to remember. What ice cream do different groups prefer? So you've got your old and medium and young, and you're looking at different flavours of ice cream, and the children like jelly, that horrible blue thing with gumdrops in it, and grown-ups like chocolate and stuff like that, and peanut butter. Okay, so it's all nominal. Peanut butter ice cream is the best. You have one sample, and it has two measures. Okay, what we mean by that is that for each person, you're going to say, what group do you belong to? Like, are you old, medium, or young? And you wouldn't say that because it would upset people. And you ask, what's your favourite ice cream out of goody gumdrops, chocolate, and peanut butter? And they choose that, and they go into one of the squares, and so you've got frequencies in your different squares in your table. And so you're going to have a table, and then you're going to end up with a chi-squared, which is then going to lead to a p-value. So it's quite impressive. You're learning 7 different tests that you should be able to do by the end of this course, and we've had 10 people pass already, so that's really exciting. Have passed the whole course. That's great. And then the last one is regression. And regression is the one that's a bit different from all of the others, because there we're looking at relationships. In the others we're looking at, is there a difference between them? In regression, we're looking at relationships between two different variables. And sometimes we could have the same data and we might want to do a difference of two means, or other times we might want to do a paired difference of two means it would be, and other times we want to do a regression. So the same data can actually be used in different tests sometimes. So here we have interval ratio. We have one sample, but two measures. And look at that, that's the same as the one above. These two here are sort of equivalent. We're seeing, is there a relationship between what people want to eat, is it ice cream, and what kind of they are. Here we're looking at, is there a relationship between the temperature of the day and how much ice cream sells, or how many choco nutties or whatever. So this one here is when you're actually ending up with some sort of line with your little dots around it. And so we get a t statistic is the value that we get for the hypothesis test, and we get a p-value. So you need to be able to replicate one of those. I'd say print out a blank one, go through, make sure you can work out what all of those things are. I wouldn't worry so much about the output because it's all pretty obvious. But what you need to do is go through your notes and find an example that really works for you, an example that you'll never forget. Like for me, it might be ice cream or something like that. Or think of examples, or use the ones from the lecture notes, so that for each of these techniques you've got something to sort of hold another one up against it. So then in the quizzes or in real life, when you've got an instance and you want to find out something, you're not sure what statistical test you're going to use, you get out your memory or whatever, or you get your little chart out and say, okay, what kind of data is it? What's it going to look like? How's it going to fit in? Is that the sort of test I want to do? And the thing you need to bear in mind is that you can actually do the wrong tests on things. It is possible to do it, and sometimes you get sort of the right answer and sometimes you don't. Just because the computer lets you do it doesn't mean that it is a valid thing to do. Okay, I'm going to give you a break for a minute or two, and me a break, and what I want you to do is have a look on page 2 and page 3, talk to the person next to you, and I want you to decide on 3 of those that you would like me to talk about.